Good afternoon for everybody. I'm Jemmy from Artawacana Christian University. I was presenting my presentation about characteristics of Kasam leaf torrefaction biomass. Introduction. The forestry and agriculture sectors are the two main resources as the main source of biomass. Low energy density, high moisture content, irregular shape of biomass, leaf biomass, low carbon content, and high tar are the main limiting factor. The limitation can be overcome by providing pretreatment before being used as a source of energy or biomass fuel. The most common pretreatment is torrefaction. Torrefaction will produce solid, liquid, and gases. Axis of method. The torrefaction experiment carried out to fulfill the research objective was based on the central composite design experimental, which was a two-factor design. Central composite design allows estimation of coefficient in second-degree polynomial regression and quadratic response surface modeling. In this study, there are two factors, namely the temperature, which is expressed as the x1 variable, and the x2 variable is residence time variable. The torrefaction temperature used is 200 degrees Celsius until 300 degrees Celsius, and the residence time is 10 minutes to 20 minutes. The interaction of resonance surface methodology with 16 randomized runs by Minitab 18 software. The approximate analysis of the torrefied was determined according to ASTM analysis method. Approximate analysis carried out is water content, volatile matter, S, and fixed carbon. The result and discussion. Approximate. The appearance of torrefied Kasam leaves at different temperature and residence times is present in table 1. Variation in color difference are a function of torrefaction. At a temperature of 180 degrees Celsius to close to 250 degrees Celsius, there was a slight color change in the Kasambi leaves regardless of the residence time. At temperatures above 250 degrees Celsius, starting with a residence time of 22 minutes, the color change in the Kasambi leaves was very significant and increased with increasing residence time. Figure 1 presents physical appearance of Kasam leaves as a function of temperature and residence time. The moisture content of torrefied Kasambi leaves varies in the range of 2 until 5%, with increasing temperature and length of residence times of volatile matter decrease. S and fixed carbon increase with increasing temperature and residence time. Summary of the result of response to moisture content, volatile matter, VM, S, and fixed carbon, FC, present in table 1. Response surface methodology analysis. For analyze response, the coefficient determination adjust, and coefficient of determination high prediction, with the difference between the coefficient of determination prediction and the coefficient of determination adjust less than 0.2 indicating a good model fit from the data obtained. The tendency to use a temperature of 300 Celsius with a residence time of 10 minutes, which result in a constant fixed carbon. Table 2 presenting analysis of variance of quadratic model respond to moisture content MC, volatilometer VM, as and fixed carbon FC. Figure 1 present contour plot and response surface temperature versus resident time. Figure 1A, moisture content, B, volatilometer, C, S, and D, fixed carbon. The conclusion. Based on the discussion on the previous page, it can be concluded that characteristic of terrified Casan beliefs can be generated using the response source methodology with a tendency to use a temperature of 300 Celsius with a residence time of 10 minutes, which produces to a constant fixed carbon. The result of this study can be the basis for future research in the manufacture of briquette using torrefied Casan beliefs. Acknowledgement. The author would like to thank the rector of Artavacana Christian University, who has provided funding through the university research camp, and chemical engineering ITB, who has given the opportunity to write in international seminar on chemical engineering Suhadi Rexwadoyo, STKSR journal. Thank you very much.